Good afternoon and welcome to the Print Think webinar series. Today we're going to be talking about data analytics. So before we get started, let me just tell you a little bit about what we'll be doing today. We will be recording this session and you'll be able to share it with other people in your organization. Just access it from the TLMI website. And if you have any questions, please go ahead and submit them in the control panel that should be somewhere on your screen after you started the webinar. And then Steve and I will be more than happy to kind of answer your questions either throughout the webinar or towards the end, kind of depending on how they come in. So at this point, we want to talk a little bit about what our webinar is. So as you all know, presses have changed a lot, or equipment in the press shop has changed a lot over the last 10 years. And you have sensors and you have all these things that are collecting data. And you start kind of wondering, what do I do with this now? You know, is there anything I can do to help me manage my business? And part of what Steve's going to talk about today is how to use those fancy gadgets that are on your presses as to how to help you analyze your business and to make more money. So at this point, I'd like to go ahead and turn it over to Steve Metcalf, our presenter today. So Steve, welcome.
Hey, thanks, Keith, and welcome everybody. Hope everybody's having a nice balmy kickoff to their summer wherever you are. I know I am. Anyways, thanks for the opportunity, and I guess we'll get right into it. Should be advancing the screen here. So again, as Keith said, the title of the webinar is Data and Analytics. It's about the digital press room, and this is really focusing more on, you know, we have machines that generate lots of data. A lot of times it's not accessible. So what can we do? And what's sort of the process now to get it accessible, and some of the things that are coming that we can all begin to utilize. So briefly about me, that's a pre-pandemic picture, obviously. I've been part of Baldwin Technology, which is a large company that has been in the graphics industry for years and years. We do everything, and I'll have a slide here in a second that'll go through what we do. But more importantly, the role that I play now is the Chief IoT Officer for Baldwin, and a platform that we've basically created called AMP, which I'll get into here in a second, which is an IoT Internet of Things platform. So Baldwin, for those that don't know us, kind of does everything. We're sort of everything but the press, but we do a lot of things on presses that make them run better and are fundamental to the process. So everything from surface treatment systems, spray systems, curing and drying, whether it's UV or LED UV, hot air drying systems, color control, color measurement, 100% defect detection and inspection, and cleaning devices, automated cleaning. So we play across the industry from narrow web flexo to big CI flexo. We're in rotogravure, we're in the offset industry, both sheet fed and web offset, and that's sort of been the traditional realm of Baldwin. But one of the things, and this is sort of part of the story today, is as we developed and acquired companies that do all of these things at Baldwin, we needed a better way to connect the data from these systems. And it all started from a service and support point of view, about 5 years ago. But as we got more into it, the depth of data, the ability to use data as an advantage became apparent. And today, Baldwin has invented something or created a platform called AMP, which is essentially, you can think of it as all of your machine data sort of into one platform. And it's, I'll get into a description of what that is here in a second. But so a little more backdrop, we hear this term Industry 4.0 or 4.0 that was coined, and really the fourth generation or revolution of the industrial, or fourth stage of the industrial revolution. And it's a little bit useful to kind of go through sort of how do we get here. So the first industry 1.0 can really be more about mechanization, as power was available to harness. The second stage was really the introduction of electricity and sort of the introduction of assembly lines using electric power as a resource. The third stage of industry is really about the computerization. So that really came around in the 80s and 90s and continues today with sort of automated production, computers, IT, robots, etc. And really the fourth stage is a lot of people think of it as smart factory of the future, autonomous systems, but it has a lot to do with IoT, Internet of Things, and machine learning, but it's really based on data, depending on where you are in the world. And so that's really the key, I think, going forward, is to just sort of remember that concept. Industry 4.0 is really about data, acquiring it, and what we can do with data once we've got it. And we have sort of a premise that we throw out, and I really haven't met anybody yet that would disagree with the statement, is that data will drive the next great advantage in the labels and packaging industry, as it will in essentially every industry, from every type of manufacturing to consumer products to even our own health. A lot of people are wearing wearables now that measure data, report data. So it's a big thing that's happening everywhere. And what's driving this, and I like to share this a little bit just to give people some context, that, you know, as most people know, there's an exponential growth rate of technology happening behind the scenes. And this particular chart comes from my favorite futurist, a guy named Peter Diamandis, who's famous for founding the X Prize Foundation for Space Exploration. But what he talks about a lot is exponential growth of technology. And this is just one way to look about it. On the vertical axis, it's basically the calculations per second of a microprocessor for about $1,000. So you can think of $1,000 if you bought an iPhone or a Galaxy phone off of contract. That's about what you spend on processing power today. And if you look at around 2022, where we are, you know, that processing power is approaching the power of the equivalent power of calculations of the entire human brain. So we're getting close to that. And, you know, about 2023, so next year, that $1,000 will have as much computational power as the human mind. And if you fast forward that through exponential growth, by, you know, hopefully within most of our lifetimes here in 2050, that same $1,000 will buy enough processing power as the entire human race, which is an astounding thing just to think about and hard to wrap your head around. But it's because of this change, this sort of driving force in tech that's happening behind the scenes, whether it's just the computational processing power getting cheaper and cheaper, more and greater all the time, as well as data storage and the hypercloud and some of the things we can do today with the biggest cloud data providers, that is making some of these things possible that we can do with data analytics, and is making this industry 4.0 real. So just to kind of keep that in mind. And we see that reflected. This is a company called IoT Analytics that monitors the global Internet of Things market forecast. And this is just an example of a chart sort of tracking connected machines, sort of globally, machines that are connected through an IoT sort of platform technology around the world. And it stalled out a little bit during the pandemic, but it's back to the projected growth rate of about 22% a year, which is really amazing when you think of all the different things we can connect from an industrial point of view. And I'm just seeing that sort of reflected a little bit in this. And one of the things I've done is sort of the best way maybe to describe what we can do with data is to almost take an approach of a case study from the future. So maybe in a few years from now, one of us or many of us could be on panels, webinars, talking about what we're doing with data and how we're solving problems. And so this is a little bit of maybe a teaser on sort of what that might sound like if we fast forwarded to a few years from now. So the first thing we might say are things like, we're now able to capture all the data generated by really all of our machines in real time, and we can do it automatically without human intervention. So it's a live data hookup to our production assets and machines. And the second thing, once we've got that, is we can compare our live and our historical data, and we can visualize our productivity, or OEE, the overall equipment effectiveness, across our machines and sites in real time. And we may say things like, we can then easily see the root cause of problems that we long suspected were there. Because a lot of us, I think, have a hunch as to what's the cause of waste or machine stoppage and things like that. But really, today's fault logs don't give us enough information. So through data, we can begin to see what was the underlying root cause. You know, was it something related to the machine speed or power or other variables that happen in the process? And we can start measuring them and putting safeguards in. So we can now measure and compare and contrast our production quality across our machines, across operators, plants, things like inks, coatings, materials, or analogs, or chemistry in the process. And the ability to do this and really use that information to set better targets, become better at running machines, stabilize quality, really becomes the next thing we can do with that. We can also identify very tiny trends that maybe only a machine can detect that could have an outsized impact on our quality. And through that, we can eliminate a majority of unplanned downtime altogether. So machine stoppages related to quality issues, et cetera, or even the machine itself, the function of the machine itself can really be tracked and sort of alerted well ahead of an event that could bring capacity to a stop. We can identify our root causes of waste and rejected product before it happens and essentially put measures in to prevent it. And we can understand the relationship between things and really the relationship between the data of things like our chemistry, our color, pressure, temperature, speed, surface treatment, curing, really anything that the press does or any machine does. We talk about the press primarily because there's a lot of variables going on there, but it could be in slitting and rewinding and other things, other aspects of production, and really ability to control for these, to get ahead of them, to understand how they relate, and to use the data to drive improvement. And we can connect we can merge live data from our machines with other data. So the machines are coming with hundreds of sensors now, which is really interesting. We still have older assets that maybe don't have these, but the ability to really add sensor data to not only just environmental data from our factory, but auxiliary information from the machines, and I've got an example of this a little bit later in the presentation, can be really powerful and can create new advantages. So understanding things like temperatures and humidities and vibration and air quality could play into things that we're doing every day, and could account for some differences between when we run something, in the summer versus a different season, et cetera. So that's a very powerful ability that is going to be coming to us pretty quickly. And we can connect and merge live data not only from our machines, but we can merge it with data from our ERP, our MIS systems, our workflows, so job data, anything that can essentially emit an electronic record that can give us data context. So the example that if you're tracking all the live data from your machine, the ability to put it into the context of your jobs, your customers, your operators, your materials, et cetera, that's going to be through these APIs, these application programming interfaces that will exist between these systems you already have, as well as these new data capabilities. And then another thing we can do is we can begin to augment the intelligence or the performance of operators and really give them tools that can put our process on an autopilot. Anyone who's buying a new vehicle these days, it went from, essentially the basic cruise control on a vehicle to essentially an auto cruise control, and now you can stay within lanes. And if you go out and buy a Tesla, you can actually have the car drive itself if you want to spend the money to do it. So this ability to sort of put the process on autopilot through some tools and through essentially making the operators better, giving them additional data about what they're doing on press, and also making it similar, between presses. So if you have different vintages of machines, there you have different brands of machines. They often are dashboarded nicely, but if there's a learning curve as you go machine to machine, control to control, to be able to sort of overlay that and pull data into a common view is going to be an important thing that can take that first step to putting things on autopilot. And this is another idea that we may be able to talk about in the future is we can now give our customers and our brand owners not just the conformity reports that a lot of them are asking more and more for, but we can give them live access to their job status if necessary. So we can use access to information of what's on a machine, how it's tracking, essentially as your job is here, essentially, and can create some new advantages for customers that through the data that we can record and collect on a job. And ultimately, I think we'll say things like this: we did it with an advanced machine monitoring platform, where fundamentally we did it with an IoT or Internet of Things platform and through live data acquisition. And so what does that really look like? And so for every production asset that you've got, from the press itself to the connected peripherals, it's really starting with the idea of data points, gathering data. There's a new vocabulary word that we'll throw out today called telemetry. The data telemetry that can be gathered from a machine. It starts with really basic KPI stuff, the machine speed, its status, is it running, how fast it's running, is it making sellable product or is it not, is it stopped or is it in make ready stage, et cetera. And then begin and putting that data into context of customers and jobs and where you're spending the time if it's not running, faults, things like that you can capture, as well as any other data that the press itself has privy to, pressures, tensions, et cetera, other settings. We can begin to pull that in and aggregate it together. And then for every connected peripheral you have on machines, and oftentimes these subsystems have as much to do with quality, or maybe even more to do with the quality of what's coming out than the machine itself. You know, the UV curing systems, the corona treatment systems, et cetera, they all have data. They have lamp power status, they have other things that they're doing that could lead us, you know, to maybe a quality or defect rate climbing, et cetera. So just understanding what's going on with these connected peripherals is also going to be of interest. Inspection systems, color systems, so we can essentially merge in information from image inspection, the defect rates, be able to monitor that, put that data together with other data happening on press. You know, so it's speed, it's you know, the other example of your EV power that's being, you know, applied to the process. We can look at waste, we can look at both, and again, both live and historical. Auxiliary sensors are things that I think we're going to see more and more of. So this is an example from one of our sister companies, AMS Spectral UV, that's essentially a live cure sensor device. So it's a device that's essentially measuring, it's made up of a number of sensors that's looking not at the output power of a curing lamp, but the actual, the output of the curing process. So the electrochemical signature of a curing reaction, unit to unit. And with that, you can begin to detect things in line, such as overcure or undercure. So a lot of things related to the process as it's flying through the machine. And, you know, sometimes we wonder, you know, is what's in that roll going to be the same as we saw during make ready? We can now sort of lock in a make ready, you know, golden image or golden step and say, okay, let's reproduce that, and let's alert our quality people to know that if we're running out of tolerance on UV, or lamps are degrading, or the operator forgot to set something, you know, we can really start to understand that data. And as customers are beginning to ask more and more for this type of information in conformity reports to support whether it's a low migration ink process, this is going to become the kind of data that creates a new advantage. So these types of things that are happening now can integrate in with that stack of data that's being extracted from the machine in real time, and of course store it for the life of the process or the machine. Another thing we can do is live data streams in, and most of the data streaming into these platforms comes in at about once every second, or even in the millisecond range. But for every piece of data or telemetry, we can start to measure it, and we can create actions. And this is an example of, you don't need to know computer programming to do this, but setting a threshold of something that we want to be notified about, and we can send an email or a text message to really one or more individuals immediately. If the press stops, for example, if the press stops before we hit a target quantity or count, you know, let's go out on the floor to understand why it stopped, maybe help the operator a little bit. So those are examples of live actioning your data. Also creating uniform live custom dashboards, where essentially put your process on sort of a visual mode, where not only quality people can watch what's going on, managers, but also you can put these tools right by the press. And the example of a radar chart there, which is showing really sort of values as they relate. So anything that might be of interest, we call that process radar. So you instruct the operator, hey, for our process, keep that blob in the green, and if it starts turning yellow, that means that something's out of tolerance, or the tolerances that we've set up for the process. Or if it turns red, you basically want to stop the press and investigate something. So this ability to kind of create live information and visual information from the live streaming data and historical data is going to be one of the other key advantages we'll have. And then also the ability to deeply interact with data. So this is an example of something we call the deep chart, where you can essentially, you are here in your data, you can navigate it as it unfolds, you can go back in time, you can look at, in this case, you can see data that's tagged to jobs, so you can see, okay, how did that job run versus the next job? Really go back into the history of information. So if a job comes up that's run before, we'll have an ability to look that up, and then, you know, very quickly apply kind of the similar runtime parameters, or understand how that ran. Think of it as sort of a job data recorder. And of course, this data can also be fed into customers for conformity reports, et cetera. So one of the other capabilities that we'll see. And so in getting there, you know, we think of it as sort of 3 steps. So the first step or stage is just getting to unlock your information, unlock your data, we call it get to know your data. So everybody's got data. It's on the floor. It's oftentimes in machines that's trapped. It's not really doing anybody good other than you can visualize it maybe at the local machine HMI control window. But really starting to do things such as putting in what we call edge device connectors to the machines that begin to unlock that information and stream it into a platform where we can begin to do these things. So begin to capture live data telemetry. This is going to require the Internet of Things sort of architectural components, and it'll require a big data platform that can ingest all the information and store it at a very low cost. And then with that, we can begin to produce some useful analytics to be able to look at both live information as it's unfolding, as well as historical data, monitor that, and then start to visualize it. So that's really step one. And then step two is once we get comfortable with our information, start putting that data to work, establishing the relationships between the data. So things, we could begin to observe this, as I said earlier, kind of the things that we long suspected were related. Now we should be able to start seeing them with data that's being aggregated. And one of the things these platforms can start to allow us to do is create our own data streams from data. So we may be able to take 2 or 3 things that are happening and aggregate, kind of create our own data stream or data telemetry based on some raw data telemetry. So things that interest us that we want to know about when this and this happen at the same time, then I want to get an alert. Those abilities will be there as well. And then now that you've got your own data, putting rules and alerts so that you can begin to act on it, get notified, take an action, drive productivity improvement, or solve for an operator learning gap, etc. And then begin to connect the machine data with your MIS systems, your ERP, your workflow to improve the context of what you're looking at and really give that next step a competitive advantage. And the third step is really, once you've got that going, is implementing data-driven autonomous action. So starting to get to sort of more of that autopilot mode of the process, where you're really unlocking greater productivity or overall equipment effectiveness, you're reducing the defects and rates and waste, you're increasing quality stability, just the stability of quality, because we can now control for things in conformity that our customers are looking for, operator ability and performance. We can augment and enhance scheduling, the scheduling process through data. We can begin to measure things like sustainability. A lot of brand owners are wanting not just to know that we're green, but that we're actually measuring it, and we can give them an energy utilization or a carbon footprint report on every job that they run, so to feed their sustainability initiatives and provide customers with data for an advantage. So really, this is about creating advantages with data at that point. And just a little sort of dropping to a level, sort of how does this happen on a machine? If you sort of think of all the different types of assets, and these are just some of the printing assets that we think of every day, is that in the middle, this sort of idea of an MQTT connector, and I'll get to that in a second, which is going to consist of a gateway. This is thing shown here is called an E1, which is a very common gateway that's been put into modern machines. A lot of these run on 5G, so they run wirelessly now. In addition to, you can wire them, you can connect them via Ethernet to your network. We can connect to presses through PLC connectors, and then just this sort of data mapping exercise. And then ultimately that flows over to the right, which is bringing that data into a platform where we can monitor it, and we can begin to do the things that I just described. An example on the platform we call AMP would be sort of you get an account on AMP, you set it up. AMP runs in the cloud. It's what we sort of refer to now as the hyper cloud. So it's running on some incredibly powerful, secure servers in the background. But essentially, what you do is you come up with a group for your entity, your sites, your users, locations, and then you start adding your machines. And then with the machines, you may have connected devices, sensors to those, or subsystems, and then you begin to build out what your data structure would look like. And now we get into this this thing called MQTT, which is actually it's a really cool acronym. But what is it in general? So MQTT is a protocol. It's an industry standard for Internet of Things systems that stands for Message Queuing and Telemetry Transport. It was developed in about 1999. And it's basically what HTML is to a website, MQTT is to data gathering into a data system that's powered by IoT. And it's a standard, and you can think of it as a publish subscribe standard. So it's not to get too technical here, but essentially the payload of every message, every MQTT message that would be flying over, off of your equipment into a big data platform would come as an MQTT message form. And it includes a telemetry section. Again, the telemetry being the data values that you're tracking, the key data values, and the actual values per variable. The context of it, that could be your jobs, your customer, your operator, other sort of static things that happen, role IDs. And then and metadata, which is just says, okay, here's what device it came from. This is the connected, this is the exact machine that it came from. And I'm not going to get any more technical than the next slide here, but this is just an example for anybody who's looked at, what a HTML page looks like. It's essentially very similar, an MQTT message as you unpack it. This is an example of the telemetry section, being some voltages, some currents and temperatures, and the actual values. And the values would be stamped every second by the controller that's basically publishing these to the IoT device. The context that comes with it could be the job name and the job ID or an operator name, for example. And then the metadata is where it came from. So this is essentially all it is to do this. And one of the cool things about this platform is that as you evolve your data, maybe we just start on a machine by connecting its speed, it's some temperature, some status information, etc. And we start transmitting that. But as we add more information, maybe we add sensors or more data becomes available from some of the connected accessories. Essentially, this MQTT template just keeps growing, and the schema, which is a database term, just the rows essentially in columns in the background keep evolving automatically, so you can continue to just add more data to your stack all the time. And that's kind of some of the ways this thing are, the flexibility of data gathering today. It is truly amazing and easy to do, and very lightweight as well. And so this is sort of behind the scenes what all this would take to make happen. I'm going to stop there and really open it up to anybody who's got a question. Keith, if you've got things that I've skipped over, you want to ask me those, be happy to address anything.
No, we had one comment that they enjoyed they commented on the bird chirping in the background. That was they made a joke, which I appreciated, that canaries in coal mines were the best early sensors back in the day. So how difficult is it to transition over from, the area where you're not collecting data and then actually finding meaningful data to use in your system or to manage with?
Yeah, so I think a lot of the companies we talk to today, it's sort of approaching it as, what if you could just start with some basic productivity information on every machine you have? What is it running? What speed is it running at? Is it making you money or not? So a lot of we were just recently at a trade event where I had a few people literally say, I just want to know if the machine's running or not. And that is, you can think of that's your sort of core value driver. That's your, the like a stock ticker for your business. Are they working? And more importantly, when they're not working, where are you spending the time? Why did they go down? What are your operators doing? So some of those reason codes that come out of that. So a lot of people can think of it starting there. The other, a lot of the newer machines and newer connected devices, certainly the devices that Baldwin has for the machines, come already ready for this. So if you spec these on a press, or if you spec a press that has these sensors, you can literally load up as much data as possible from the machine control itself or from the controllers of these devices, and they're essentially ready to go to feed you information into this stack. So it's really could be as simple as 1 to 2 to 3 data points, or it could be hundreds of data points if it's maybe a production or workhorse machine that you really want to understand more about what's going on. And the same goes for software, integrating the data points from electronic job ticketing systems, such as the label tracks, is something we're working on right now, so that context can overlay into the data.
Okay, so we have a question from someone in the audience asking about essentially pricing, which generally for any webinar that we do, generally someone always will go to that. So pricing for systems like this, you're going to be looking at per machine, as a per user. How are the different pricing models for different companies, and how do they come about that?
Yeah, we believe, and actually this is sort of the pricing model that we're coming into the market with, is essentially per connected machine. So it scales from the level of data and the value of that machine to you in the organization. So a good example, our pricing actually starts at $49 a month per connected machine for up to about 10 data points, so basic productivity information. And that could be, think of it a little bit more as a proxy for the machine value. That might be useful for a slitter rewinder or something that's that you can think of it like your billing rate. If you go up to, say, a production like a narrow web press that maybe starts to get into a realm of several hundred data points, the pricing kind of starts scaling up to maybe 200 an hour, or $200 a machine per month, which is sort of, again, a proxy on 1 hour billable time of that press, maybe on average is about 200-ish, and if you can gain 1 hour productivity a month through using data, you've hit an ROI point on that. And then as machines scale up and get more and more data, the pricing can scale up from there. So, we've got customers that are looking at sort of an enterprise-wide contract, but you don't need that. So this is sort of, I call it, this is sort of, this new wave of this is not your father's software acquisition model. This is basically, kind of a no commitment. It's a software as a service utility. So you essentially just sign up for what you need. And with signing up comes support and things like that, onboarding support, and how do you start getting things connected?
Okay. Another question from the audience. So the context data for specific jobs, that type of information. So job ticket IDs, employee information, is that manually inputted, scanned in from barcodes? Describe some of the things that you have or you've seen in the industry.
So most people are familiar with a job package or job ticket that comes out of their MIS or their ERP system. And today, if you're doing that sort of a paper-based system, in your ERP and MIS is electronic record of that. So what AMP has is an API, an application programming interface, that can receive data from a typical job system. You could think of it sort of the standard job data would be sort of a JDF, JML type format. But basically there would be a publish subscribe from that. So as jobs get queued up on machines, that can automatically flow into a platform like this, but it can also be augmented right at press. So, the sort of the matching or the mirroring of the job data or the job that's being queued up on the schedule to what's actually running on the machine. There's a bit of an operator intervention saying, okay, this job is starting to run, or the machine has the job code, so we can automatically tag that. Another ability that will be in these systems is to start recording not just the data, but the notes as the job ran. So as operators are making notes, if a machine stopped, why did it stop? Tracking some of that history sort of, for the next time we run a job will be very easy to do. So essentially there's kind of think of it as an augmented process to move data electronically to the press side, so we can then tag the data that's running on the machine, record it, and then do something useful with it, send it back to estimating, so you'll have actuals tracked very quickly, or expose data to customers if they're interested in looking at job status.
Okay, well, we have another question here. Which ERPs do you work with for data integration?
So good question. So we're taking, I guess one way to say it is all of them, but we're taking an approach of developing an API, so AMP is sort of surrounded by APIs, which can assist the import of data or the subscription of data into the platform. One of the companies we are working with, so we're starting with market leaders. So LabelTrax is, if anybody's running a narrow web process in the US, they're probably at least familiar with LabelTrax, if not running the software. So that's an example. But as you look across the industry, AMP is sort of an open platform, and the idea is to work with really all the big names of the tech providers that we use every day to keep our machines running and keep our business running.
Okay. If there are any other questions, please go ahead and submit them. But in the meantime, I'll go ahead and start our wrap up. Like I said, I will check to see if there are any other last minute questions, but I'd like to thank Steve for a great presentation, very informative. You didn't go too nerdy on any of us, so we were able to kind of keep up with you. So we do all appreciate that. As a reminder, this webinar is being recorded and will be shared on the TLMI website. So you'll be able to see it at a later date, watch it with other team members, or share it with other members of your organization to where you feel it might be appropriate for your company. So let's double check. No last minute questions. Steve, I would like to thank you. I'd also like to thank the TLMI team for helping put all of this together, the work that they do, and most importantly, everybody who is in the audience. I'd like to thank you for being here as well, and we look forward to seeing you next time. Thank you so much and have a great day.
Thanks, everybody.